All right, this is the Unit 4 review sheet. Number 1 says to solve. So just like an equation, I want to try to isolate my x. The x is stuck to -2, so I'm going to do the opposite of adding 1 to move that 1 away to the other side. So I subtract 1 on both sides. That leaves me -2x is greater than 5. The opposite of multiplying by -2 is divide by -2. But don't forget that special rule that we have to reverse the inequality, and then we would get -5/2. For all of these, you can use Desmos to check them. So this is what was given to me. This was what I got, and they are the same graph. So I know that that answer is correct. For the next one, it says to solve for y. So think about putting it into slope-intercept form. I want to move that, which is y equals mx plus b. I need to move this 2x to the other side, so I subtract 2x. Because the 12 and -2x are not like terms, I just put them beside each other. My last step here is to divide each part by the -3. Keep in mind that when you divide by a negative, you must reverse that inequality symbol. We'll end up with y is greater than 2/3 x minus 4. I can check that answer in Desmos, and I see that it is the exact same graph. On the next one, I'm trying to get this x alone. I'm going to subtract a 4 on both sides. -2x is greater than 6. Divide both sides by -2, which makes me reverse the inequality. I get x is less than -3 for my answer. Put in the original inequality that they gave us. Check your solution. They should match. Number 4. Remember, if you're using Desmos, you're going to have to change this to be x's. But the first thing I need to do is clear my denominator of 2, so I have to multiply every single thing by 2. These 2's cancel. I'm left with n plus 3 is greater than or equal to. These cancel. I get n plus, and when I multiply 1 times 2, 2. My next step is to move the n's to the same side. I'm going to subtract an n on both sides. This n cancels out, and this n cancels out. I'm left with the inequality that 3 is greater than or equal to 2. This is true, which means the solution is all real numbers. The way that that looks in Desmos, I can zoom out as far as I want. Every single number is going to be shaded, so every single number is a solution. This next one, I'm going to have to distribute this -8 to solve. That leaves me with 3n minus 8n minus 8 is less than 12n minus 12. Combine my like terms here. That gives me a -5n minus 8 is less than 12n minus 12. Do not have enough room, so I'm just going to add a little box real quick so that I can continue working on that. So here, I want to get all my n's to the same side. I'm going to subtract 12n because I like for my variable to end up on the left side. That gives me -17n minus 8 is less than -12. Add 8 to both sides. -17n is less than -4. I keep the sign of the bigger number and subtract. Last thing is to divide by -17 on both sides. When you divide by a negative, your inequality reverses, and this will just be 4 over 17 because a negative divided by a negative is a positive. When I look to see where that original inequality, which was right here, I changed it to x's, but 3x minus 8 times the sum of x and 1 is less than 12x minus 12. This is the graph I have. I got this answer that x is greater than 4/17. So 4/17 is correct. They are the same graph. The next one, I want to get the n's on the same side. I'm going to subtract 4.50n from both sides. And that gives me 7.5? I think it's a 7.5n is greater than 135. When I divide both sides by 7.5, I end up with n is greater than 18. Another way that you can do these, so once I type in this original inequality right here, I can see that everything that's shaded is greater than, or the number's bigger than 18. So n is greater than 18. The reason it's only greater and not equal to is because of that dashed line. But either way, I can check my answer, and I do see that these are the same graphs. I'm just erasing this so I can see this problem again. All right, and this next one, solve and plot it on a number line. I'm going to subtract 5 on both sides. I get negative 2x is greater than negative 8. Divide both sides by negative 2. Keep in mind when you divide by a negative, you reverse your inequality. Negative 8 divided by negative 2 is a positive 4. Hollow circle because it's less than but not equal to, and it shades this way. If you put that into Desmos right here, you'll see that the x is on the 4, it's a dotted line, which means it's not included, and everything to the left is shaded. How many solutions are there to this inequality? Every single number, and an arrow goes on forever, so that tells me it's an infinite number of solutions. Which of the following are possible solutions? So all I'm looking for that is I'm trying to see if the x, when I put in a number, if it shows up in the shaded area. X equals negative 10 is showing up, so that's correct. X equals 5 is also, nope, it's not showing up in the shaded area. It's outside the shaded area, so that's not right. X equals 0, that is right here. It is the shaded area, so it's a yes. X equals negative 5, right there, it's a yes. X equals, I think I moved this around. I don't know where 44 went. Let me move that 44 right there. Oh wait, I know what happened. These, yeah. X equals 8. That is not in the shaded area. X equals negative 6 is in the shaded area. X equals 44, definitely not in the shaded area. X equals negative 4 is in my shaded area. X equals 16 is not in the shaded area. X equals 4. X equals 4 is actually on the line, but because the line is dashed, that means that we can't have those points as solutions. So this one, where was I at? Negative 4, no, positive 4. Here. This is not a solution because that makes it have a solid line. If it had a solid line, it would be, but in this case, it's not. X equals negative 22. If I go down, I can see that it is in the shaded area. And then finally, x equals 9 is not in the shaded area. Let me turn this graph off. and off. All right, the next problem here. Sam cannot work more than 20 hours. We want to express that as an inequality. X is the amount of hours he's working, and it cannot be more than, so it has to be less than, and it can be equal to 20. Sam needs at least $240, can be represented as his amount has to be greater than and can be equal to 240. All right, the words less than is this symbol. Less than or equal to is this one. Greater than or equal to. At most means it can be exactly that or less than. So it's less than or equal to. Does not exceed, meaning it can't go past that number and it can include that number. So that's also less than greater to. At least means I want the number to be bigger or the same. Keith has $800 in his savings account at the beginning of the summer. He withdraws $29. That means he takes $29 out of it from his account each week for food, clothes, and movie tickets. He wants to have at least $100 in the account by the end of the summer. So he starts with $800. Each week he takes away $29, and my variable X is the number of weeks. And what he has left, he wants to be at least $100. So this amount has to be greater than or equal to $100. Willow is driving on the freeway. She just passed mile marker 325. She will not drive faster than 64 miles per hour, though there is a bit of traffic that might slow her down a bit, but she doesn't know exactly how much. The mile markers are increasing on her route. If Y is Willow's speed, which inequality represents her speed, it says she does not drive faster than 64, so it has to be less than or equal to 64. All the information about the mile markers was just extra information. Number 15, Bob is ordering pizza for a birthday party. He has a total of $220 to pay for the pizza. Each pizza costs $15, and the company charges a fixed delivery amount of $12. Our goal is to find out what is the most number of pizzas Bob can order. So think about Y equals MX plus B, but we're going to use it as an inequality. Each pizza is $15, so X is number of pizzas. So I'll have 15X plus that beginning fee of 12, and this amount has to be less than or equal to 220. I want to solve that, and let's just go look at Desmos for that one. 15X, here it is. I see that it's at 13.8 repeating. So let's just say that X is going to be less than or equal to 13.9. So that means he has to order less than 13.9 pizzas, so he can order 13 pizzas. I know that typically 0.9 you were taught to round up, but in this situation, if we went up to 14 pizzas, he would not have enough money. 16, the gardening club at school is growing vegetables. The club has 400 square feet to plant seeds. Cucumber plants are 5 square feet to grow. Tomato plants are 3. The students want to plant some of each type, and they want to have at least 50 plants. Let C be the number of cucumber plants, T is the number of tomato. Let's start with our square footage. Each cucumber is 5, so 5 times C, plus each tomato is 3 times T, and this amount has to be less than or equal to 400. I can't have more acres than 400. The second one is talking about the number of these. The number of cucumber plants plus tomato plants, it has to be at least 50, so that means it can be greater than or equal to 50. Graph these. So I'm going to do that in Desmos. right here and look at where it's intersecting. I see that it's going through, actually I'm gonna go to this point here. This point here, it's going through 1, 1, 1, 1, and 0, 4. 0, 4 is right here, 1, 1 is right here. It is a dashed line, so I'm just gonna do dashed. And the shading is up to the other side, to the right side. The next one is a system. I graphed the first line and the second line. So let's start with just the first line. It goes through 0, 3, right there, and I want another pretty point that it goes through. I'm going to use this point -4, 2. So it goes through -4, and the y value of that was 2. -4, 2, and 0, 3. That is a dashed line, so I'm going to dash it. It's shaded below. Sorry. All right, the next part of that, the second inequality, I'm going to turn this one off, is y is greater than -x plus 4. I see it crosses at 0, 4 and 4, 0. So 0, 4 is right here, blue, right here, and 4, 0 is here. I see that it is a dashed line, so I'm going to dash the line. I see that it's shaded up to the right of it. So I'm going to shade this part up here. The solution is that overlapping area right in here. So all of the points in this area are solutions. Number 19. And you could have also just plotted them both at the same time and seen that it was this part here. The next one, y is less than 5/4 x minus 5. It goes through the -5 and the +4. So my y-intercept is -5. X-intercept is at +4. And I see that it is a dashed line. It is shaded down to the right. The second inequality is going through 0, 8. And let's pick a pretty point right here. It looks like it's going through 2, 2. So 2, 2 is here, and 0, 8 is here. It is a solid line, so I'm going to draw a solid line. The shading for that is happening down to the left. My solution to the system is this area of the overlapping shaded region. And it could also be on this purple line, to be correct. On the next one, it says a jeweler makes silver and gold chains. She sells the silver chains for $100 each and the gold for $30 each. Her monthly expenses are $3,000. The jeweler makes a profit if her total monthly sales are greater than her expenses. So I need to set up an inequality for this. The X, I can see that X is talking about the gold chains. Gold chains are $30, so 30X plus $100 for the silver chains. Silver is the Y value, so 100Y. And this amount has to be greater than $3,000 for her to make a profit. So when I graph that, I see that it goes through the 0, 30, and 100. So this is not it, this is not it. And it has a dashed line, so this is the correct one. On the test, you have a problem like this, but it's different prices and the words are in different places. Last problem, a jewelry artist is making selling necklaces at a fair. It's $150 to rent the booth, and that is where we get this $150 here, and $3.75 for her expenses to create the necklaces. The sale price, the amount she's gonna earn, is $14 times the number of necklaces. Represent this situation. So let me go ahead and graph that one. And then it's asking me if 15 is a solution.
Yeah, exactly.
I see that it is in the shaded area, so yes. Explain why. Because it's in shaded area on Desmos. Robin, did you finish that? And tomorrow you can make up that test.
I was supposed to make it tomorrow. I just did it.
You did the whole test?
Well, I
In the
already was
Chromebook?
doing it. I was already doing it.
Oh, you just hadn't finished.
hadn't finished.
So you finished it already? I can take you off of my full list for tomorrow, so go choose one.
Okay.
All right, another word, never mind. Let me just set this equal to n. All right, now I'm going to subtract 3.75 n on both sides. And that gives me 10.25 n is greater than 150. Next thing I do, divide by 10.25. And I'm going to use Desmos to help me with that fraction. So right here, to simplify the fraction, what it's going to be, n is going to be greater than 600 over 41. And I can see that that is matching that original graph. It's the same graph. So I know my answer is correct.